So today we're going to talk about isosceles and equilateral triangles. Alright, we'll start with some vocab terminology. An isosceles triangle is a triangle with two congruent sides called the legs. The non-congruent side is then called the base. Then we have an equilateral triangle. All sides are congruent. That's the definition of equilateral, so we have three congruent sides. Alright. So basically when they tell you that you have an isosceles triangle with a base, BC, that tells you the other two sides are congruent. So when I start my proof, alright, I start with that statement, isosceles triangle ABC with base BC. And that is given. So where you go from there is if they give you the bases BC, you're allowed to say AB is congruent to AC. That is the one thing that we'll do that will fall under definition of isosceles triangle. Alright? Everything else is going to be isosceles triangle properties when we do a proof. Alright? So then AD bisects angle A. Alright? So there's angle A. I'm going to label them with numbers, and I'm going to say angle 1 is congruent to angle 2. Alright? Definition of angle bisector. Whereas this was the given. Alright. Then AD is the shared side. So AD is congruent to AD. Reflexive property. Alright. That gives me that. So now you notice we got the congruent triangles. Just make sure you match up the corresponding parts as always. So triangle BAD, congruent to triangle CAD. Reason being side angle side. And angle B is congruent to angle C. We learned in the last section that would follow the triangle proof of CP. Alright, that will always be the case, ladies and gentlemen. If we have two sides that are congruent, these angles are also going to be congruent. And that's going to be the isosceles triangle property we'll talk about in a second. Listed in Theorem 4.3, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. The congruent angles are called the base angles. The non-congruent angle is called the vertex angle. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. That's the converse, which means you can write it in biconditional format if we want. Two sides of a triangle are congruent if and only if the two angles opposite them are congruent, and vice versa. Alright, so now you know, you don't have to prove it again, the base angles are always going to be congruent. Alright. So now, if we add some things, we're going to add some more CP/CTC to our proof. Alright, so here's what we're going to say. We're going to say that those angles are congruent as well. Alright, so angle 3 is congruent to angle 4 as well. So we'll put that under one category. Alright, in addition, BD will be congruent to DC. Alright, all by CP/CTC. Okay, so we went B and C, so that told us the angles 3 is congruent to 4. Well, you also notice 3 and 4 form a linear pair. That means that we are allowed to then say that those must be right angles. So we're going to say angle 3 and angle 4 are right angles. Congruent angles forming a linear pair must be right angles, which means those lines are perpendicular. In fact, BD is congruent to DC, makes D a midpoint, which brings us to our last part of this, AD, perpendicular bisector of BC. Definition of perpendicular bisector. Alright, so basically what we're saying is, Theorem 4.5, if a line bisects the vertex angle of an isosceles triangle. And the line is the perpendicular bisector of the base. Alright, so what it is it's a sale. You buy one, you get two free. In terms of math, if they tell you any one of the following, the segment bisects the vertex angle. Segment from the vertex to the midpoint of the opposite side, or the segment from the vertex is perpendicular to the other side. Alright, you know the other two must be true. So if they give you one, you need to know you have the other three. And then today's notes finish up with what we call corollaries, a theorem that can be proved easily using another theorem. Corollary to theorem 4.3, if the triangle is equilateral, then the triangle is equiangular. If a triangle is equiangular, then the triangle is equilateral. Alright, both are true, so that means we could write in biconditional format, but here's the idea. Those two sides are congruent, so those angles have to be congruent. If I rotated 120 degrees, these two sides are congruent, so those angles are also congruent. Well, by the transitive property, if two angles are congruent to the same angle, then they must be congruent. Boom. All three angles have to be congruent. Alright, the next video we'll go through some practice problems, but that's the notes. Be good.